Alright, so 1.4 is comparative advantage, which is probably the first big skill-based thing that you've got to learn that can show up on the test. So ultimately what we get into is we're going to start talking about trade initially. What's the goal of trade? Why did we start trading as a society? And then talk a lot about efficiency. Why certain producers should produce goods that are more efficient for them to produce, ultimately based on their availability of resources. But all right, so why do we trade? Well, we trade so that we can gain things that we don't have to produce ourselves. If we were to produce here in Alabaster everything that we needed in life, well, we're going to produce a lot of probably mediocre things. That if we got to produce everything, we can't produce everything great, and so we got to sacrifice some quality for quantity and kind of produce a bunch of average goods. But if we focus on goods that we produce really well and specialize in those goods, then we can trade with other producers that specialize in other high-quality goods. And it benefits everybody and kind of lifts everybody up, because if everyone's producing these really high-quality goods and we're all trading with each other, then we have access to all high-quality goods instead of producing all mediocre goods ourselves. So trade and specialization benefits everyone. But it's based on what goods and services am I more efficient at producing. And it's going to come down to opportunity cost. Whoever has the lowest opportunity cost in production, meaning whoever has to give up the least amount of resources in order to produce that product, is the person that should produce it. And so we're going to see examples where, I may be able to produce more than you, but you're more efficient at producing than me, so therefore you should produce it, even though I can produce more than you. But trade helps everybody. Specialization helps everybody. So absolute and comparative advantage. And so what we're doing is we're comparing two different producers now. And so the key point of that I highlighted, cost is not always money. And so we're going to see that today here in a second, is that opportunity cost and what you give up a lot of times is in terms of resources, not always the actual monetary value of something that you give up or how much you have to spend to make something. So kind of ingrain that cost is not a monetary idea. Cost is anything you have to give up. So assume it costs us $50 to produce 5 t-shirts. What is our per unit cost for each shirt? $10. And so if we put a monetary spin on it, now I'm going to teach it to you both ways. A lot of this I'm going to teach to you in terms of resources, because that's what College Board wants. But I'm also going to explain it in terms of money, because a lot of times that makes more sense, because we're used to money being our primary cost. But anyways, if we produce 5 shirts for $50, it's going to cost us $10 per shirt. Now, if we produce either 5 shirts or 10 hats is our two options. And this is kind of like PPC, is that we've got 5 shirts, we've got 10 hats, or some combination thereof. Well, what is our per unit opportunity cost for every shirt that we produce? Every time we produce 1 shirt, how many hats could we produce? 2. So every time we produce a shirt, we could have produced 2 hats. And the easiest way I can explain this is that we've got this big pile of fabric, essentially, and that is our limited resource. So with this big pile of fabric, we can either produce 1 shirt or we can produce 2 hats. But we can't produce both with that pile of fabric or whatever that resource is. It's only enough to produce 1 shirt or 2 hats. We've got to make that decision. Which one are we going to produce? Well, if we decide to produce 1 hat, what do we give up now in terms of per unit opportunity cost? Flip it. Half a shirt. So now we can either produce 1 hat or half a shirt with the same amount of limited resources available to us. So that's our opportunity cost. For every 1 shirt, our opportunity cost is 2 hats that we could have produced. And then every time we produce a hat, we could have produced half a shirt. Opportunity cost in terms of what did you give up because of the choice that you made. All right, so we got 2 producers. We've got Ronald McDonald and we've got Papa John. Ronald can produce 20 pizzas or 200 burgers with the resources available. Papa John can can produce 100 pizzas or 200 burgers with the resources available. So what we're trying to decide, who's going to be the more efficient producer of burgers, who's going to be the more efficient producer of pizzas. They should specialize and then trade with each other in theory. Remember, this is a theory and concept class. Ronald and Papa John are not going to get together and physically trade hamburgers for pizzas. It does not work like that in the real world. But in an economic sense, it does. So remember, don't take this as literal as you can. But this is what is Ronald's opportunity cost for one pizza in terms of burgers given up. So every time Ronald produces one pizza, how many burgers could it be produced? 10. Good. All right. Every time he produces one burger, how much of a pizza did he give up? 110. Good. You're going to figure out, when you go from one product to the other, you can always take the reciprocal. You just flip it. We're going to see that when we actually start working with our comparative advantage grids. But some of y'all are starting to pick up on that. It's just the reciprocal of whatever you gave up before. But there's a bunch of shortcuts I'm going to teach you with this too, that you'll be able to do these really quick once you get in the habit of them. But 3, what is Papa John's opportunity cost for one pizza? 2. Good. 2 burgers. And then what is his opportunity cost for one burger?
1/2.
Half of a pizza. So, what we look at now, we've essentially put it into like terms. We have our per unit opportunity cost, and that's the big picture idea here, is per unit opportunity cost. So, every time Ronald produces a pizza, he could have produced 10 burgers. Every time Papa John produces a pizza, he could have produced 2 burgers. Who is the more efficient producer? Papa John. So Papa John should specialize in the production of pizzas. All right, Ronald produces 1 burger at the cost of 1/10 of a pizza. Papa John produces a burger at the cost of 1/2 of a pizza. Who's the more efficient producer? Ronald. Ronald should specialize in burgers. Papa John should specialize in pizzas. In theory, they should trade with each other because they can produce it at a lower opportunity cost. In terms of resources they have to give up in order to produce the product. How do you feel about that?
Good.
You get the idea in terms of resources given up? Okay. All right. Absolute advantage is easy. If you can look at 2 numbers and determine which is the bigger number or which is the smaller number, you can do absolute advantage. And it's just who can produce more. Well, who can produce the most or who can use the least amount of resources. There's going to be 2 types of comparative advantage problems. I'll show you. Input and output, we'll get to all that. But absolute advantage, you just look at 2 numbers, if you can figure out which one is bigger or which one is smaller, you can do absolute advantage. Example, Papa John has an absolute advantage in pizzas because he can produce 100, Ronald can only produce 20. Or Papa John has the absolute advantage simply based on the fact he can produce a greater number. It doesn't mean that he's the most efficient, it just means he can produce the most. Comparative is who has the lower opportunity cost per unit. It's the comparative advantage. That's who should really produce the product because they give up the least amount of resources to produce it. They're the most efficient producer. So many things in this class all come back to efficiency. Who's the most efficient when it comes down to it that should produce a product? Okay. All right, so we got 2 PPC curves there. We've got USA, we've got Brazil. We're looking at the production of sugar. We're looking at the production of wheat. And big thing, I just want you to realize that we're taking that PPC curve, and now we're putting those numbers, I don't want that yet, into this. This is what we're going to be working with. Is you're going to have this grid. And on the left, you're going to have your 2 producers. On the top, you're going to have your 2 products. Always set it up that way. Always set it up with producers on the left, products on the top. Because once I teach you the shortcuts, it's going to give you the right answers. If you set it up backwards, it's not going to work. So always set these up. Producers on the left, products on the top. All right, if we take these numbers from our PPC graphs, we can see that the United States can produce 30 tons of sugar or 30 tons of wheat. Brazil can produce 20 tons of sugar or 10 tons of wheat. Just looking at if we produce all sugar or all wheat, what is the possible production of these 2 countries? So we plug our numbers in. That's where those numbers come from there. Now, well, first of all, absolute advantage. Who has an absolute advantage in wheat? Who can produce more? U.S. Who has an absolute advantage in sugar?
Brazil.
U.S. So we'd say the USA has an absolute advantage in both the production of wheat and sugar, purely based on the fact that they can produce a greater quantity. I'm going to do this a little bit different. I'm going to write on it. So I'm going to show you my way of doing things. Make it simple. I'll do that. Does that work? Look at green. Green's fine. All right, so we've got to get our per unit cost. So what I'm going to teach you to do, we're looking for the opportunity cost of 1 ton of wheat for both producers. I need the opportunity cost of 1 ton of sugar for both producers. And what we're going to do is we're just trying to get our like terms. All right. This is an output problem. We're going to look at output and input. But output is talking about the total overall amount being produced. When we get to input, it's talking about the amount of resources needed to produce something. The amount going in versus the amount going out. There's an acronym we use for each. For an output problem, we use the acronym OOO. Output other goes over. Output other goes over. And what that means is we're going to be bringing these values across. And so other goes over, other goes over, other goes over, other goes over. Set up your fractions like that. Simplify. What's 30 over 30 simplify? 1. So that tells me for every 1 ton of wheat they produce, their per unit opportunity cost was 1 ton of sugar. Same thing here, 30 over 30. Every time they produce 1 ton of sugar, they could have produced 1 ton of wheat. Here, 20 over 10 gives us 2. Shortcut, just take the reciprocal. It's always the easy way to do it. You can work it out. 10 over 20 is 1/2, but you can always just flip it. So, every time Brazil produces 1 ton of wheat, they could have produced 2 tons of sugar. Every time they produce 1 ton of sugar, they could have produced 1/2 ton of wheat as their opportunity cost in production. Compare your numbers. Which is less, 1 or 2? 1. The United States has a comparative advantage in wheat, which is less, 1/2 of 1, 1/2. Brazil has the comparative advantage in sugar. So the United States should produce wheat, Brazil should produce sugar. 2 countries should trade in theory. If this is weird, hang on, it's going to make more sense once you start working hands-on with it. But this is what we're going to be doing. This is called comparative advantage. Looking at 2 producers, determining who is the most efficient producer and who should specialize in production of that product. A shortcut to this. We've already said the United States has an absolute advantage in both products, which is okay. You cannot have a comparative advantage in both products. So like if we figure out the United States has a comparative advantage in wheat, automatically you're going to know Brazil has a comparative advantage in the other product. A country cannot have, or a producer cannot have, a comparative advantage in both products. It's always going to work out where it's one or the other. It's now absolute, they can have both. Comparative, they cannot. Now, another example. And I know I'm in y'all's way. I'm trying to get out here. Here, I'll go to this side this time. So, output question. The way you determine this can be kind of tricky, though. The only way to determine input from output is in the wording of the question. Now, there's some key words when we get to input that will help you know, hey, we're talking about the amount of resources going into something. But ultimately, it comes down to the wording of the problem. That's the trickiest part, is determining is this input or this is output. Because if you get it wrong, it completely changes everything about how you set it up. But with practice, you'll be able to determine, hey, just by reading this, I'm either talking about the amount of resources going in for an input problem or the total overall amount being produced output. But anyways, we got 2 producers. We got Japan, we got Canada, we got 2 product CDs, In beef, we know this is an output problem, so our acronym is OOO, output other goes over. So, well, to set it up first, we need the opportunity cost of 1 CD for both producers. We need the opportunity cost of 1 beef for both producers. Get it there, bring the values over. So 2 goes over 4, 4 goes over 2, 6 goes over 4, 4 goes over 6. Simplify 2 fourths is, well, running out of room. 1 CD, so 2. So when I simplify it, I just leave it like that, 3 halves. Some of y'all are OCD and it has to be 1 1/2, which is fine. I don't care as long as you get the right answer. But 3 halves, you flip it, the reciprocal is 2/3. I do it that way because it's simpler. But anyways, go through and compare. Which is less, 1/2 or 3 halves? 1/2. So Japan has a comparative advantage in CDs, which automatically tells us Canada has to have the comparative advantage in beef, but 2/3 is less than 2. So based on their per unit opportunity cost, Japan is going to produce CDs, Canada is going to produce beef, and the 2 countries are going to trade. If we look at absolute advantage, both countries can produce 4. If it's ever the same, neither country has an absolute advantage. Don't say that they both have an absolute advantage. They can't both have an advantage. So you say neither country has an absolute advantage in the production of CDs. Who has the absolute advantage in beef? Canada. They can produce more than Japan. That's your absolute advantage. Questions so far? We're starting to get the idea here. And a lot of this is just repetition, just doing it hands-on.
So they cannot, wait, so a country can have, wait, okay, never mind. Sorry.
All good?
Something, but I got it right now. So in this situation, the CDs and the beef are, like their production is related to each other?
No, we just have 2 random products.
But then it wouldn't cost a CD to make beef. They can produce both at the same time.
Don't use common sense here. We're just talking trade-offs. Purely opportunity costs. Remember, it's all theory. It's not, in the real world, it's nowhere near this simple as far as how production actually goes on. This is just a concept looking at a producer should specialize in the products that they have the lower opportunity cost for.
Couldn't they have used better examples?
What?
Couldn't they have used better examples? Like
They could have, but
like
they're not
beef,
going to.
beef and lamb, beef and venison,
Yeah.
They could
even
have.
any other type of food, not CDs.
CDs and, any other form of technology.
I
CDs
think
and
so.
hard drives.
Go ahead and get used to the weird examples in here. Like they'll throw out some weird stuff, but the products don't matter. You can pick 2 completely random products. You can honestly ignore the products. Just look at the numbers. It's all based on calculation how you determine this. Products have nothing to do with it. Products are there to just kind of help you set everything up. That was my input. All right. Oh, these are a little bit more similar. Bread and corn.
Okay.
We're kind of getting closer now. So, all right. So an input question. Now we're talking about the amount of resources needed to go into something for production. Keywords include, if you're producing one of something, typically it's an input question. If we're talking about the amount of something needed to produce one, it's an input question. It's not always the case, but typically more times than not. It's talking about hours, and a lot of times the number of hours needed to produce something, it's an input question because time is a resource. College Board loves using bushels of agriculture as a unit. I don't know why, but they've done it time and time again. Typically, if we're talking bushels of agriculture needed to produce something, it's an input question. But just look at it as, am I talking about the amount of something needed to produce something? So it says, the chart illustrates the number of hours it takes. And that's another thing. If it says it takes or it needs, those are the keywords telling you it's an input problem. But the number of hours it takes to produce one loaf of bread, or there we go, one bushel of corn, which is an actual agricultural unit that's sold. But this is an input question. But anyways, acronym for input, IOU. Input, other goes under. So now, instead of bringing values over, you're going to bring them under to set up your fractions. So, we need to find the per unit opportunity cost. We don't want gray, go green again. One bread and one corn. IOU, other goes under, and so now 2 goes under 4, 4 goes under 2, 6 goes under 4, 4 goes under 6. Now we simplify. 4 halves simplified is 2. Flip it for the reciprocal. 1 half bread. We got 4/6, which is 2/3 corn, and then 3 halves bread. Comparative advantage is always the lower per unit opportunity cost. So once you get to this point, it is always the lower per unit opportunity cost. Which is less, 2/3 or 2? 2/3. 2/3. So France has a comparative advantage in bread. Therefore, United States has a comparative advantage in corn, but 1 half is less than 3 halves. Comparative advantage is always the lower per unit opportunity cost for input. For both. Comparative advantage is always the lower. Always the lower per unit opportunity cost. The reason that's important, absolute advantage for an input question is the lower of the two. So output, absolute, is higher. Absolute input is lower. There's a lot of rules to this that get tricky, but like I said, with practice, it's fine. But both can produce 4. Neither has an absolute advantage. United States can produce 2 corn. Well, look at it this way. It takes the United States 2 hours to produce 1 unit of corn. It takes France 6 hours to produce 1 unit of corn. We produce it essentially 3 times faster than France. That gives us the absolute advantage. We use the least amount of a resource to produce 1 unit. That gives us the absolute advantage. So for input, absolute is smaller. Output, absolute is bigger. Comparative advantage, where you're bringing everything across, is always the lower per unit opportunity cost. Whoever can produce it with the lowest per unit should always specialize in that product. How are we? Okay?
Do you have any graphs of absolute input and absolute output? Like how it's comparative advantage and then absolute advantage but with input and output?
Like the PVC curves? Or?
Well, more like the table of the France, US.
Things say I don't have it, but you can set it up. So then you would just say USA, France, corn, Oh, yeah? Like, okay. Yeah, you can just set up a simple grid for it. And this, once again, y'all are going to get a lot of hands-on practice with this. I think I've actually got like 2 different sheets. One of them is concept, one of them is just drill and kill, where you're just doing hands-on practice with this. Just working through. Because, I mean, it's easy to get tripped up. The concept isn't that bad. The concept is easy of why a producer would specialize based on the lower opportunity cost. The tricky part is remembering all these stupid rules of getting the right answer. And so that's where you have to practice. It's just remembering, oh, this is that, that's that, I do this, that goes there. You get the idea. All right, terms of trade. There's a really easy shortcut for this I'm going to show you. But basically, terms of trade is what is an agreed upon trade that would benefit both producers. You know, X amount of this product traded for X amount of this product would benefit both producers in trade. Because trade should benefit both sides. You know, you don't want to make a trade that only benefits one producer or the other. That's not a fair trade. And so we want to find what is an acceptable trade deal that would benefit both producers. And like I said, I'm going to show you a really easy shortcut to find it on the grids, but that's what we're talking about in terms of trade. What's a trade deal? You know, if this was set on the table, I will give you this amount of this for X amount of that. Does it benefit both sides? So we got two producers. We've got Kenya and we've got India. We've got two products, pineapples and radios. Oh, don't freak out, because they are not similar. And this is where we jump off the diving board into theoretical economics, because we're going to be producing these two products based on a given set of resources. So, anyway, this is an output problem. Okay, to help you out, we're talking about the overall amount being produced. So, Kenya can produce 30 pineapples. India can produce 40. Who's got the absolute advantage? India. They can produce the overall greater amount for an output problem. Kenya can produce 10 radios. India can produce 40. Who has the absolute advantage? India. So India has an absolute advantage in the production of both products because they can produce an overall greater amount. Remember, only one of them will have a comparative advantage in each product once we get to it. So now, let's get our questions up there. We'll start setting everything up. So we need to find the opportunity cost of one pineapple for both producers and one radio for both producers. We know our acronym is OOO, output, other goes over. And so we can go ahead and set it up. Well, I'll just bring them across. 10 goes over 30, 30 goes over 10, 40 goes over 40, 40 goes over 40. Now we simplify. 10 over 30 is what? 1/3. 1/3 radio. Take the reciprocals, the easy way to do it. 3 pineapples. Here, it's equal. So we know that's 1 radio, 1 pineapple. So, in theory, every time Kenya produces 1 pineapple, they could have produced 1/3 of a radio. Every time they produce a radio, they could have produced 3 pineapples in terms of resources. India, every time they produce 1 pineapple, could have produced 1 radio. Every time they produce 1 radio, could have produced 1 pineapple. Who has the comparative advantage in pineapples? Kenya. Good. 1/3 is less than 1. Kenya can produce it for 1/3 of a radio. It takes India a whole radio to produce it. Kenya is the more efficient producer in pineapples, which automatically tells us India has the comparative advantage in radios, but 1 is less than 3. So Kenya should produce pineapples. India should produce radios. In theory, they should trade. Once again, these two countries are not going to sit down at the same table and start trading 1/3 of a radio cut in half for a couple pineapples. In theory, they are though. Well, that's 6. So who should import pineapples? India. Okay, good. Because they're going to produce radios, they're going to import pineapples because they're not going to produce them. All right, so number 7 gets us into terms of trade. It says trading 1 radio for how many pineapples would benefit both countries. The shortcut to finding an acceptable terms of trade is easy. It is a number in between those two or a number in between those two. For simplicity's sake, what's the only whole number between 1 and 3? 2. So we're going to say the proposed trade deal is 1 radio for 2 pineapples. That will benefit both countries. That's the shortcut. Any number in there, any number within that range. Now, when you get to the test, if College Board says, all right, give me an acceptable terms of trade for 1 radio, you can be that person who goes, all right, 1 radio for 1.2795543 pineapples. Don't be that person. Just choose 2. Make the life easy for the reader. We'll talk about that. If you get on the reader's good side, that's in your favor. So, but anyways, anything within that range, anything from 1.01 to 2.99 is technically going to benefit both countries. Here's one. I don't know if I want to do this in money first or not. Let's not. Let's do it in terms of resources, and then I'll go back and explain it in terms of money. So, we know India is going to specialize in radios. If they were to produce, let's look at it this way. Okay, every time they produce a radio, they could have produced 1 pineapple. But if they could take their radio and trade it for 2 pineapples, that's a good deal. They're gaining more than trade than it would have cost them to produce it on their own. If Kenya was going to produce the radio, they're not, but if they were, they would have to give up 3 pineapples. Well, if they can take 2 of their pineapples and trade for a radio, that's a good deal. They're getting it for less than what they could have produced it themselves. In monetary terms, it costs India $1 to produce a radio, but they sell it for $2. Is that a good deal? Yes, because they're selling it for twice what it costs them to make it. If it's going to cost $3 for Kenya to produce a radio, but they can buy it for $2, is that a good deal? Yes, they're buying it cheaper than what they can produce it in-house. So monetarily, it makes a lot of sense. In terms of resources, you kind of get lost in the weeds as far as pineapples and radios. But it's in terms of what would it cost to produce it versus what do they get. India gains more through trade at 2 pineapples. Kenya gets it for a cheaper rate than what they can produce it themselves. If you don't get the concept, just pick a number in between. You're going to be right. Questions? Okay. When y'all get quiet, it's either a good thing or a bad thing. I never know which. It gives you another example there. If the terms of trade for 1 radio is greater than 3 pineapples, then Kenya is worse off and shouldn't make radios on their own. So, in monetary terms, if Kenya said you're going to owe us $4, or in theory 4 pineapples for a radio, well, Kenya can go, no, I can produce it for $3 or 3 pineapples myself. Why am I going to give you 4 when I can produce it for 3? That makes no sense. 4 is outside that range. That's why that does not work. Same thing here. If they want less than 1, it's not going to work. Voila, trading 2 pineapples for 1 radio benefits both. We've already talked about why. We can come back to that. What's next? It gives you more examples there. Okay, and that's the last slide. I can leave those up there.